Welcome again. This is a continuation of the main topic, approximation and measurements. And in this lesson, we'll be looking at significant figures. In the last lesson, we looked at how we actually round off decimal numbers. Now, what's the difference between a decimal number or decimal point? What's the difference between a decimal number and a significant figure, or decimal points and significant figures? For the decimal points, the total number of digits is typically to the right of the number, while for the significant figures, the number can actually start from the first non-zero number, which can actually be on the left of the decimal point. Now, in order for you to identify the number of significant figures in a number, you need to be able to, you need to memorize the golden rules or the rule of thumb. So these are the rules. Number one, all non-zero digits are actually significant. And we're going to look at examples of each of these coming up. All zeros between non-zero numbers are also significant. All zeros to the right of the decimal point and at the end are always significant. All zeros which are to the left of a written decimal point and are in a decimal greater than or equal to 10 are always significant. So this is pretty much the rules that you have to familiarize yourself with. But we're going to see how these actually play out by looking at different type of number and identifying the number of significant figures in each and assign the rules that governs them. So in this number 48,923, which digits in this number are actually significant? All of them, because they are all non-zero numbers. 4 is significant, 8 is significant, 9 is significant, 2 is significant, 3 is significant. So it is said to consist of, the number is said to consist of 5 significant figures. Right? So that pertains to rule 1. Let's look at the second number below, which is 3.967. We want to identify again how many significant figures are in that. So first thing we need to do is to look at the digits that are actually significant, right? So 3 is significant, of course, because it is actually a non-zero number, and therefore all the other numbers in there are actually significant because they are actually non-zero. However, it's a decimal. Although it is a decimal number, all the numbers there, right and left of the decimal, are actually non-zero, so they are considered to be significant. So here we have 1, 2, 3, 4. So we have four significant figures in this number. Let's now consider the third number here, which is 900.06. Now, question to ask yourself is, which numbers in here are significant? And we can see there that the 9 and the 6 there are actually significant. So that is actually 2 significant figures already, because they are actually governing rule 1. They're actually governing rule 1. So here we have 9 and 6 as being significant. You can just indicate those. Now we're going to then consider if these zeros are actually significant based on the rule here. What does it say about zeros? Now we have leading zeros as we call them, and we have one trailing zero here in a decimal. And the rule says that all zeros between non-zero numbers are significant. So we expect that these zeros will be significant. So that will apply to rule 2, right? So, as well as, and it also says that all zeros which are to the left of a written decimal point are significant. So what this is basically saying for is that that trailing zeros, once it is in a decimal, it will be considered to be significant. So therefore, in total, we have 1, 2, all of these are actually, so we have 1, 2, 3, 4, 5 significant figures. Now, let's look at the fourth number, which is a decimal number, and it's 0.0004. And which one of these rules you think will this number will actually govern? And basically, and can you infer then how many significant figures are actually in this number? Yeah, there's one significant figure in this number, which is 4, and that is actually a non-zero number, right? The rule says that trailing zeros that are not between or sandwiched between non-zero numbers, those will actually be insignificant. So therefore, the only significant number here is digit here is actually 4. Okay. 8.1000. How many significant figures are in this number? So we realize that 8 is actually significant, so we can indicate that. Check the number. 8 is actually significant, as well as 1, because they're both non-zero numbers, and the rule says that trailing zeros, which are zeros that come after the decimal, they are significant, right? Once they are a part of a decimal number. Once they are a part of a decimal number. So in total here, we have 1, 2, 3, 4, 5. We have 5 significant figures there. Let's look at the last one, 10.0. How many significant figures are in this number? Is it 1? Is it 2? Is it 3? There are actually 3 significant figures in this number. Which one of those rules does that govern? All right, so as you can see there, one is a significant number because it's a non-zero number, and all zeros to the right of a decimal are significant, are always significant. Good. And if the number are always significant. So again, we have 1 here, which is a non-zero digit, so that will be significant. And then it says that all zeros to the right of the decimal point and at the end are always significant, so that 0 will also be significant. And then number 4 will also apply as well. So all zeros which are to the left of a written decimal point, right, are always significant. Let us know. You can put these in, right, to identify which one of those rules those are. Now, how many significant figures are actually in these quantities? So we can see here that 5 is actually significant because it's a non-zero number. And these leading and trailing 0, because it's a part of a decimal, they are actually significant. So here we have 1, 2, 3, 4, 1, 2, 3, 4, 5 significant figures. Good. And again, that very important. They are actually significant because they are they are within a decimal number. Now this one has only one significant figure. One significant figure. Why? Because so of course 3 will be a significant figure because it's a non-zero digit. But these zeros are actually not significant because they are not a part of a decimal. So we only have one significant figure there. Now number 3 here, how many significant are in that number? Well, 2 and 9, as we know, they are significant because they are non-zero. And what can we say about these zeros? Are they significant? These 4 zeros, will they be significant based on the rule there? Will they be significant? They will not be significant. Why? Because they are not existing between, they are not being sandwiched between two non-zero numbers, nor are they, and of course, the digit to the left of the decimal here is actually a 0 and not a non-zero number. So that's what makes it, that's what makes it have two significant figures. What about this one, number 4? Of course, 8 and 9 are actually significant. This 0 is actually not significant because it's a trailing 0 and it's a non-zero number. Now, these zeros are actually sandwiched, good, or they exist between two non-zero numbers, so they are considered to be significant. So in this number, we have 4 significant figures. Okay. Now, what about number 6, which is an interesting one? So we have 3 here, we have 5 there, we have 7 there, and we have 5 there. And these are all significant. Now the question is this 0 significant and is this one significant? Yes, they are. Now, this is actually a decimal. This is actually a 0 that is to the left of the decimal place, and this is also a 0 that is to the right of the decimal place. Good. Now this 0, for example, exists between two non-zero numbers, so it will therefore be significant. And this 0 here is actually significant because it is actually a 0 that comes after a decimal point that is within a decimal, and we consider that to be significant. So therefore, we have 1, 2, 3, 4, 5, 6 significant figures. Okay, what about number 7? Number 7, how many significant figures that will have? We can work this out, right? So that would be 1.00 times 10 times 1,000, right? And that will give us 1,000. So how many significant figures this will have? Of course, 1 here is significant, and these zeros here are not significant because they They are not a part of a decimal, so they are not considered to be significant. So we only have one significant figure in this number. What about this one, number 5, that we jumped over? Okay, so this is significant, that's significant, that's significant, that's significant. So we have now this this 0 which comes after the decimal point, good, or what we call a trailing 0, and this one is actually sandwiched. So we do know that that will actually be significant because it exists between it exists between two non-zero numbers. Now this 0 here will not be significant, right? Because the number that is left of the decimal point there is actually a 0, and it is actually not a non-zero number. So in this number we have 1, 2, 3, 4, 5. We have 5 significant figures. So the key to understanding how to identify the number of significant figures in a number is to basically walk through the rules, okay, and then assign the rule that applies to the number. All right. Thanks for listening and watching. Until next time.